we're going to start chapter 2. We just finished that chapter 1 on matter, and we talked a little bit about physical and chemical changes and what matter was and how matter works. And now we're going to talk about the different states of matter, and this is kind of what this whole chapter is about, at least the two sections we're going to do in this chapter. One deals with the different states of matter, and one talks about phase changes. How do we change from one state of matter to the next? And then we'll get into chapter 3, which is on the periodic table. So we'll start here. The reading material can be found. I'm going to be posting that on PowerSchool Learning. And so each section, it'll be the teacher's edition, but in case you didn't bring your book home, this will help as far as when you get to do your homework. Anyway, that will be posted, so if you want to read through that, or if you want to use that to help you with your homework, either way. So we're going to start in the first section. This is again on states of matter, and the first one is solids. Okay, so solids have a definite shape, definite volume, which means it cannot change. You know what a solid is. You know that if you have a shoe or a book or computer even, if you put it down, it stays the same shape. If you put it somewhere else, it stays the same shape. It doesn't change at all. So the reason for that is they have fixed close pack arrangement of particles. And as you can see in this picture right here, kind of, it's probably not super obvious, but there's these little, I don't know, they kind of show that the particles are moving a little bit, and they do. The solid particles actually vibrate back and forth just a little bit, but they stay in place, so they don't come out of place very easily unless something happens, like they're melted or something like that. So basically the behavior of solid molecules is that they stay put. They don't move around a lot. They do move a little, but they don't move around a lot in order to, it won't change shape basically easily. So here they are in a container. You'll see as we go through, the same container is used for all three states of matter. And this one sits in the container, doesn't take the shape of the container, just looks the same. Okay, so there's two different types of solids, because we can always talk about, well, this solid acts a little different than this solid. The main one that we talk about when we think about solids is crystalline solids. So these are ones that are arranged in a regular pattern, which means they don't change. It's very difficult to make them change their shape. But amorphous solids are different. So if you think about butter or plastic, those types of things we know can kind of soften up and maybe get a little bit more pliable before they melt. That would be what we call an amorphous solid. So its particles are not arranged in a regular pattern, which means they're easier to break apart. So when they start to heat up a little bit, they start to kind of loosen up, start to make a puddle of butter there, or the plastic, if it's been left out in the heat for a long time, you can kind of tell it's pretty bendable, maybe even starts to melt a little, lose its shape a bit. So those two are good examples of amorphous solids, which means they don't have a repeating pattern to them. Okay, so next, our next statement is liquid. And liquids have a definite volume, which means that no matter what, they're the same volume. No matter which container you put them into, same volume. And the one thing about them, though, is they don't have a regular shape. A solid has a regular shape no matter what container you put it into. But as you know with liquids, if you put a bigger amount of liquid into a smaller glass, it might overflow the glass. Or they're showing you here, these are both 100 milliliters of water, but one's in a graduated cylinder and one is in a flask. And because of that, they look differently. They look like a different amount, but they're the exact same amount. They take the shape of their container, which again is shown over here in this particular picture, and it shows that the particles are able to move past each other. You can see that by the arrows that they're showing. These arrows are showing that these are constantly moving around. And so these arrows are just showing how those particles move, and they don't stop. Even when they're put into a different container, they're always kind of moving around. And that does not allow them to take a certain shape on. That's why they can take the shape of the container that they are in. There's also a couple different properties of liquids to talk about here, and two of them are surface tension and viscosity. We've talked about viscosity before with different things, but that's resistance to flowing. So for instance, there are thicker liquids and there are thinner liquids. Those that are thicker have a higher viscosity. Those that are thinner have a lower viscosity. So for instance, like honey would have a pretty high viscosity because it's just a thicker liquid. Syrup has a high viscosity, especially if it's cold. You'd think that syrup has a high viscosity. Something like water would have a very low viscosity because it flows very easily. The other property is surface tension, which we've worked with before. There's a picture here of this little water strider as it walks on top of water, or how water beads up there on the leaves. And last year, even in 7th grade, the first little scientific method activity we did dealt with surface tension, where we put drops of water, on a penny to see how many we could fit on there. And the reason why they stuck together is because there's a lot of cohesion that goes with water molecules, but also there's surface tension, which kind of allows it to make like a pretty strong surface there. So the water is very strong on the top. So if you get it like the top part of the water kind of like adheres adheres stronger than others, and because of that, things can kind of sit on top like the water strider. Okay, so the last state of matter are gases. Gases are substances that can change volume and shape very easily. So as the particles move past each other, they're constantly filling the space available to them. So we've gone through all of this. Solids have a definite shape, definite volume. Okay, they keep the same shape, always the same volume no matter where you put them. Liquids are a little bit less, so they don't always have the same shape, but they definitely keep the same volume no matter which container you put them in. For gases, they have neither. No definite shape, no definite volume. In fact, the difference between this picture and all the rest of them is that there's a lid on this container. It's the only way to contain a gas into one spot is to basically put it into a container and seal that container. And then you kind of can talk about how much volume and stuff the gas has. Now, some other things deal with the volume of gases. Gases are their own special things to the point where we have to talk about different things you have to do with gases in order to talk about like their volume and their shape and all that kind of stuff. So that goes to a little bit deeper explanation. But for the most, what you can think about right now is that particles do not have a definite shape or a definite volume. Gases do not. And you can see in here that these molecules are moving around very, very quickly, and that's how gases work. Gases are kind of like the hottest of all of these because the particles are constantly moving around, and when the particles move around, they gain energy, and energy causes heat and all of that. So these particles, in order to be a gas, they have to be pretty hot in order for them to be a gas. Now, depending on what type of gas it is, depends on how hot they need to be to stay in this state. Obviously, oxygen doesn't need to be super hot because it stays oxygen gas even when it gets really, really cold outside. So it has to be really, 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 really cold to freeze oxygen. Just like, if you ever heard of dry ice before, carbon dioxide is dry ice is solid carbon dioxide, and so it's really, really, really cold, which you actually can burn your skin on it because it's so cold. Anyway, so the particles there have to be, they're heated up, and they have to be fairly cool in order for them to solidify into first a liquid, and then into a solid. So those are the different types of states of matter, that is the solids, the liquids, and the gases. There is homework on this. It's a worksheet that you can either print off yourself from PowerSchool Learning, you can pick up at school. If you need me to email it to you, let me know. You can have your parents send me an email and I can email it out to you. Or you can just look at the one that's on PowerSchool Learning and write the answers on a sheet of paper. The way to send things back into me, and I've gone through this on an email with your families, you can take a picture of it and send it to me. Probably be the easiest at this point. So enjoy!